couple things can happen when we're talking about continuity on an interval. It could be the fact that it's continuous on an open interval. So in other words, the endpoints may not be continuous. You may have a place where both endpoints is continuous at both endpoints, or maybe just one endpoint is continuous. Remember, we bracket it if we're including it. We use a parenthesis if we're not including it. Like I mentioned, in these examples, I want to know the interval where the function is continuous. All you're going to do is look at the domain. Basically, this is not asking for the type of discontinuity at a particular x. It wants to know the interval where it's continuous. So all you're basically going to do is state the domain. That's it. All right? So this goes back to what you studied back in Algebra 2. You guys studied square root functions last year. How did you find the domain of square root functions? What kind of number cannot be underneath the square root and remain in the real number system? Negative. So to find the domain of any square root function, you have to take whatever's underneath the square root and make it what? Greater than or equal to 0. Because remember, you can take the square root of 0. So x plus 5 is greater than or equal to 0, so then x is going to be greater than or equal to negative 5. So now let's translate that into interval notation. So we bracket negative 5 to infinity. And again, you use a parenthesis, remember, after infinity. So there's the interval at which this function is continuous. You guys studied cube root functions last year. What was the domain of your cube root function? Oh, remember that graph of a cube root function looks something like this. They're kind of a slithering looking S. I always think it looks like an S. So remember, the domain of cube root functions, you can take the cube root of a negative number, you can take the cube root of 0, you can take the cube root of positive numbers. So this function is going to be continuous for all real numbers, from negative infinity to infinity. Again, finding the continuity over an interval is just stating the domain. All right, now let's take a look at C. So you have a couple things you need to consider when talking about the continuity of this particular function. First of all, you've got a fraction. What kind of number can never be in the denominator of fraction? 0. So I know no matter what, to find this domain, since x is in the denominator, I know it's got to be greater than 0. And it's the fourth root. I cannot have a negative number underneath of an even root. So how am I going to find the domain of this particular function? I'm going to take what's underneath the radical, and I'm going to make it what? Greater than 0. Can it be greater than or equal to 0? No, because again, if this fourth root was not in the denominator of a fraction, you would make it greater than or equal to 0, because I could take the fourth root of 0. But the condition you have to consider is the fact that this radical is in the denominator. You cannot have 0 in the denominator, so it's got to be greater than 0. How do you solve this? Spent time a couple weeks ago solving quadratic inequalities. How do you solve this quadratic inequality? Factor it, find the critical numbers, and do the number line test. So see if you can finish this. Factor it, find those critical numbers, and see where